We're going to be looking today to use some of the logarithm stuff. We've been doing all unit to solve some exponential growth and decay problems. So these are going to be kind of more word type problems where you're going to have to set up and then use logs to solve. First one on your note says certain assets like homes can appreciate, which means increase in value over time. Others like cars depreciate or decrease in value with time. So it says, suppose you buy a car for $22,000 and each year the value of the car decreases 16%. Write an exponential function in the form we've been looking at that could be used to model the price of the car. Write the function in terms of x, the number of years since you purchased the car. So what we have here, same equation we've been using here. This is your start amount. Y, like it said, is the ending amount. X, that's your number of times. Okay, and then B would be our multiplier here. So in this problem, we are writing the equation. So we got y equals here. We know the starting amount, $22,000. Okay, our multiplier we're going to have to figure out here, and we don't know right now what time we're going to be putting in. So the big thing we got to figure out is what is our multiplier? Well, they said it's decreasing by 16% each year. Okay, so we know if we're decreasing 16, that's minus 16%. We got to figure out what are we actually minusing from? Well, the total is 100%. Okay, so we got to do 100% minus 16%, which is 84%. And that becomes our multiplier. Now, the same thing we could do, remember when you're putting in the equation, we're going to have to do this as a decimal. If we change 84% to a decimal, that's 0.84. That's going to be our multiplier because we're doing 100%, which as a decimal is 1, minus 16% as a decimal is 0.16, and we get 0.84. So 0.84 is our multiplier. So that equation now can be used to find the value of the car 2 years later, 3 years later, 7 years later, whatever year we wanted to find, we could do that. So let's find out what these are. This is where the equation's nice because now we can do all these calculations very quickly. All we have to do now is put the time in for x, and we can do that. So if we want to find it after 2 years, we got this equation here, 22,000, 0.84 to the power of 2. So all you got to do is go on calculator and type that in. Exactly how it looks there, and we can find out how much the car would be worth. Looks like after 2 years, the price went down from $22,000 to $15,523.20. So you can see decreasing 16% each year dropped the value. If you want to do 3 years, okay, same thing, same equation. Nothing changes except our exponent. Our years now is 3. So do the same thing. Type the same equation in here. 22,000 times 0.84 to the power of 3. And looks like this one is 13,000. So relatively easily you can get then the prices of the car. Why don't you pause the video here, see if you can find out what this would be now for 7 years. So what do you get when you do 7? All right, let's check it. If you did 7, you should have used 7 as your exponent. If you did it right, it should be $6,491.99. So pretty close to $6,492. So that is using exponentials and doing that. And you guys did some of this earlier in the unit. What we're going to be looking at today is what if you don't know the time and you got to find the time out. So we're going to be looking more ones where you're not sure on the time and you got to maybe find out what that is. So let's look at this next example. We're going to look at some decay ones first, like the one we just did. When you're decreasing over time, your fixed percent, you want to subtract that percentage from 100. So this 1 minus r here, what that really is saying is it's 100% minus whatever percent you are decreasing here, r percent. And as a decimal, that would be 1 minus whatever this your percentage is as a decimal. So you're putting that in for your multiplier. All right, let's try one out. The first one says a cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half this caffeine to be eliminated? Okay, so we want to start with our equation here. We know it's a decrease in one because it's going to be eliminated, which means decreased from your body. So we're going to use this equation here. And we know we're going to be subtracting the rate from 100%, or from 1 if we turn it into a decimal. So here our starting amount is 130. Okay, we know that our thing is 11% here, so we can either do 100% minus 11%, get 89% here, and turn this into a decimal of 0.89, and then just put that in, or you can change 11% to a decimal, subtract it from 1, and it's going to be the same thing. So if we do that, you get the same thing of 0.89. Okay, but we need to figure out what is our ending value going to be. They said how long will it take for half of this caffeine to be eliminated? Well, we can figure out what half of 130 is. 130 divided by 2 here is going to be, what is that, 65. So 65 is our ending amount. So this is the equation now that we need to solve. All right, to solve this, we can't multiply the 130 and the 0.89 because the 0.89 has that exponent. We got to do exponents before we multiply. So instead of multiplying here, we're going to have to do the opposite and divide by 130. So that's the first step in solving. On this side now, this is going to equal 0.5. Okay, now here's where we get stuck. We can't use any algebra tricks anymore to solve this one. So when you get stuck and you got this exponent you can't solve for, this is where we know we got logs. Logarithms will help us solve it. And you can either use common log or natural log here to solve. It doesn't matter. Either one will give you the same answer. I like to use natural log. You can use regular common log if you want. So we're going to log both sides. And what that allows us to do is take our exponent that we don't know of, use those log properties, and move it down. So now we got natural log of 0.5 equals the time multiplied by this log. Now we can solve and get t by itself by dividing. So if we divide these two logs out, we will get our answer here. So on your calculator, do log of 0.5, natural log of 0.5, divided by natural log of 0.89, and we get our solution. It should be about 5.9 hours it'll take to eliminate. Now, I said it didn't matter which log you did. If you had done the same thing with common log, you would have pretty much get the same answer, except the natural logs would be common logs. Watch if you would have used common log. I'll type the same thing in with the same numbers, just both of them common logs, and you get the same exact solution. So it doesn't matter which one you want to use, whether it's common log or natural log, both of them end up with the same solution there. So either way, the time ends up being about 5.9 hours. All right, let's try another one out. The second one says the store is offering a clearance sale on a certain type of digital camera. The original price of the camera is $198. The price decreases 10% each week until all the cameras are sold. How many weeks will it take for the price of the cameras to drop below half the original price? I want you to pause and see if you can set this one up all by yourself and see what, if you have the correct equation here. Okay, let's see how you did. The starting amount or initial amount we know is 198. Okay. The multiplier we're going to be able to figure out, this is a decrease one. 1 minus, it's 10% each week. 10% of the decimal is going to be 0.1. We don't know the time. We do know the ending amount though, or we can solve for it. They want to know when it drops below half. Half of 198, or 198 divided by 2 is going to be $99. So we want to figure out when it gets to $99. All right, now why don't you pause again, see if you can solve this equation out now that we have it and see what you get. All right, well, one thing we can do here is we can simplify that parentheses. That's going to end up being 0.9. Now to solve, hopefully the first step you did was to divide by 198 because we can't multiply that number. There's an exponent. We got 0.5 on that side and we got 0.9 on this side. Now, in order to solve this one, we're stuck unless we log both sides. So now you got to do log of both sides. And it's, as long as you do the same one, you should be fine. Now use your log properties, bring our exponent down, and then we can divide to solve. So if we divide both sides by natural log of 0.9 here, we should get the solution. And if you do that correctly on your calculator, you should get the answer. So let's check. Here you got log of 0.5. Make sure you close parentheses up like we've talked about in previous notes, divided by natural log of 0.9. And it's going to take about 6.6 weeks, it looks like, for that to be drop below half. All right. The other type of problem you might get is exponential growth. It's the same thing. If it's growth, though, you want to add your percentage growth onto 100%. Okay, as a decimal then, 100% is 1, and your rate would be whatever the rate is as a decimal that you'd want to put in for your thing here. So number 3 says, in 1910, the population of a city was 120,000. That looks like our starting value. Okay, since then, the population has increased 1.5%. So we got 1 plus as a decimal. Be careful with this one. 1.5% as a decimal, not 0.15. We got to move it over twice or divide by 100 here. Looks like we're going to have to fill a 0 in there. So it'd be 0.015. Then it says, if the population continues to grow at this rate, what will be the population in the year 2010? Okay, so now we got to figure out, is that 2010, is that the ending amount or is that the time? Well, this looks like a time here. So this one we actually can fill in our exponent. We do have to figure it out though. What's the time going to be in this problem? Well, if we're ending at 2010 and we began at 1910, how many years is that going to be? Looks like 100. 100 would be our exponent. This one isn't going to require any logarithm to solve. This is just a pure calculator problem. All you got to do is type this in and you should get the answer. So 12,000 times 1 plus 0.015 all to the power of 100. So it looks like the population 100 years later is going to be 531,845 people. So if you know the time, it doesn't require logs to solve. If you don't know the time, you're going to have to use logarithms to solve. All right, number 4, another population problem. Let's read through it. It says the population of a city is 1 million and then is increasing 3% per year. The population continues to grow at this rate. How many years will the population have doubled? This one's going to require us to use logs here because we don't know the time. So let's fill in what we know. 1 million is our starting amount. Our rate is increasing. It's 3% as a decimal. That's 0.03. We don't know the time. We do know the ending amount, though. It says how many years will the population have doubled. If the population doubles, there's going to be 2 million people here. Okay, so now what we have to do is solve this out. We know we can't multiply this, so we're going to have to divide by 1 million. And if we divide both sides by 1 million, 2 million divided by 1 million is going to be 2. Okay, on the other side, we got, if we add that up, that's 1.03 to the t. There's no more simplifying we can do right now. So what we're going to have to do here is logs. Do the log of both sides. Common log, natural log, it doesn't matter. I'm going to use natural log. So natural log of both sides. That's going to let us move our exponent down using log properties. And now if we divide, we have our answer. So divide both sides by this. Now it's just a calculator problem. So on your calculator, type it in, you got your answer. Natural log 2. Again, make sure you always close up that first parentheses with the other side, and then natural log 1.03. It looks like it's going to take around 23.4 years for this population to double. All right. The next one, there's always usually a couple of these on the ACT test. So here's a standardized test practice question. Home values in Millersport increase about 4% per year. Mr. Thomas purchased his home 8 years ago for $122,000. What's the value of his home now? Why don't you pause the video and see if you can pick the correct solution. If this was like an ACT test, which one would you go with? All right, let's check out, see how you did. We know the starting value is $122,000. It's an increasing one by 4%, so we want to add, if it's increasing, 0.04, not 0.4. And then they do tell us the time. It was 8 years ago. That's our exponent. We're not going to have to use logs on this one. You should just be able to put that in your calculator and solve. If you do it right, you should have came up with C. C was the correct value there. Okay, a couple more. Another type of exponential one you might get is when you have exponential decay. And exponential decay kind of involves continuous decay of something. And when it's continuous decay, then E gets involved. Remember our natural number E? So then our equation becomes this: y equals a e to the negative kt, where k is a constant. It's the same equation for growth, except that our exponent's no longer negative, it would be positive. So if you have compound growth or compound decay, then our equation turns into this one with E. So in these types of problems, K basically becomes our constant. It's kind of a growth constant. It's kind of like R. It's pretty much like R. So we could also write this as a e to the RT. Okay, same with this one. This could be written as y equals a e to the negative RT. R, K, it's our growth constant. So let's read through this problem. Number 6 says the half-life of a radioactive substance is the time it takes for half of the atoms of the substance to disintegrate. All life on Earth contains carbon-14, which decays continuously at a fixed rate. The half-life of carbon-14 is 5,760 years. That is, every 5,760 years, half of the mass of carbon-14 decays away. What's the value of K and the equation of decay for carbon-14? So in this problem, since we know it's decay, we want to start with this equation, y equals a e to the negative kt, because it's decay, so we want to choose the one with negative. And then we got to put in what we know. Well, they tell us in this one this year of 5,760. So we know what the time is. The time is going to be 5,760. We don't know what k is, because that's what they're asking us to solve for. And so we need to figure out what are we going to put in for the starting amount and ending amount. Now, did they ever tell us the starting or ending amount? Well, if you look at the numbers here, we've used this 5,760. Is the starting amount 14? No, that's just a description word of what they're doing here. Carbon-14 is like a compound. So we're not using 14. They didn't really give us any other numbers. It doesn't really matter in this case, though, how much we're starting and ending with. The time's going to be the same no matter if you start with 1,000,000 or 5. The time it takes for half of it to decay is going to be the same. So there's a couple options for you to do when this happens. You can either make up your own numbers, or you can use the variables listed. I'll show you. let's just say we had started with 10 of carbon 14. Well, we want to know how long until we have half. That's what half-life means. How long until half of it's left? Well, what is half of 10? 5. Okay, now watch what happens when we solve this. We would have to divide both sides by 10 here. And when we divide by 10, the left side is going to turn into 0.5 or half. Okay, so we'd get that. Now I'll show you another option you could do to do this. Instead of making up your own stuff, you could just use the variables they gave you. We know our starting amount is A. If we want to end up with half of what we started with, well, what's half of A? It would be half of A. Okay, if we were going to solve this one now, instead of dividing by a number, we would divide by whatever this A is. Well, that cancels out and that cancels out, so what's left on this side? 0.5 or half. So it doesn't matter if you want to make up your own or use the variables. 0.5 is what should be on that side if we want to find half-life. All right, now we get to this part in the equation. We don't have anything else to do with algebra. Now we got to add logs in. In this one, we definitely want to use natural log because we are using the natural number, e here. So now at this point in the equation, add natural log to both sides. Okay, and we can use our log properties again to move our exponent down. And the nice thing here about using natural log is that natural log of e, like we talked about in previous notes, is 1. So that's gone. So we're just left with that negative 5,760k. Last step, divide, and we can find our answer. So if we divide by this number, k is by itself now. So we can figure out what that k value is going to be. So now use your calculator, type that in, and we can find the value. So natural log of 0.5, close the parentheses up, divided by negative 5,760. And it looks like the k value for this is listed on a calculator there. Now be careful, it's really easy to write the answer as 1.2. Okay, because if you look at that number on there, you see right at the beginning 1.20, so yeah, it's pretty close to 1.2. But if you look at the end of all this, notice at the end, there's this E, capital E, negative 4. That means your calculator is telling you this is a scientific notation number. So it's not 1.2, this means 1.2, and since it's E, capital E, negative 4, that means times 10 to the negative 4th power. So that is our k value. This is a small number. If you wanted to write that out as a non-scientific notation number, we would have to move the decimal point 4 places to the left. So if we did that, 1, 2, 3, 4, looks like you'd have to fill in with 3 zeros. Another way to write this k value would be 0.3012. That would be the k value of this one. So either that, or you could definitely leave it in scientific notation too. So that's half-life. If they're asking half-life, they want to know how long till half of it is left. So your starting amount doesn't matter. Your ending amount should be half of that. All right, one more of these. It says for a certain strain of bacteria, the K value is 0.872 when T is measured in days. Using this formula, so this is the growth one for continuous growth. How long will it take 9 bacteria to increase to 738 bacteria? Okay, so 9 bacteria, that's our starting amount. We know our K value. They told us here it is 0.872. We don't know the time, so we got to leave T in there. We do know the ending amount of bacteria is this. So now we just got to solve this out and see what you get. Start by dividing by 9. And if we divide that by 9, that's going to be 82. Okay, now we're stuck here. So this is where you want to put in logs. And since we see E, we definitely want to do natural log of both sides. Okay, so we got ln of 82. We know ln and e are opposite, so on this other side we end up with 0.872 times t. Looks like to solve this one now divide. And we should get our answer. So if you divide that out on your calculator, it should come up that it takes about 5.05 days. So very close to about 5 days for the bacteria to grow to that. All right, try some of these out on the practice.